Across a quiet ocean of deep time, Ton 618 glows like a lighthouse that never sleeps. A river of fire circles an ultramassive heart, winds rise as pale banners and light bends, lingers and returns as a calm unbroken tone. Telescopes listen across radio-infrared, optical and X-ray bands, turning flickers into a map of halo, host, disk and horizon. This is a lullaby written by gravity, gentle, patient, irresistible. The journey moves inward layer by layer toward the brink where silence rules and wonder deepens. In the far hush beyond familiar constellations, Ton 618 breathes a steady radiance that takes ages to cross the thin intergalactic night, a lullaby written in falling matter and curved time that arrives as a calm, continuous tone. From such distance, the quasar looks like a single unwavering point, a pearl of brightness suspended in blackness. Yet within that point the pace is relentless, as gas threads inward like a slow river that gathers speed until it becomes a roaring cataract, each spiral closer to the centre, releasing heat light and whispering winds. The surface of the inward river forms a disk wide on the outer rim, and hot near the core where friction and magnetic tangle turn orderly orbits into a glowing sheet that spins and shines, and this light stretched and reddened by the deep well of gravity sets the rhythm of the cosmic song. To an attentive listener, the radiance does not glare, it soothes. The steadiness means that countless small flares blend into a gentle glow, and the distance smooths every sudden rise into a soft curve so that the engine of extreme physics becomes across space and time a keeper of even breath. Light carries news of the place where gravity is the most persuasive voice. It hints at temperatures that would strip atoms at speeds that brush the edge of light itself, at orbits that shrink and tighten until the path becomes a surrender, and yet the combined news becoming a cradle for the mind because the pattern repeats and the repetition invites rest. All across the quiet, the quasar marks its presence as a beacon from an era when galaxies are young, when the web of matter threads itself into long filaments and heavy nodes, when the first great cities of stars learn to build and unbuild themselves. Here a black hole of rare size anchors a luminous core that outshines its host, and the host in turn sits within a halo of dark matter that bends motions like a slow tide, unseen yet firm. The halo draws in cold gas along the surrounding filament, and that gas becomes food for the disk, and the disk converts that food into light and the wind travels outward to stir the outskirts, where new stars wait to rise. The result is a grand exchange between centre and surroundings, a slow conversation carried by gravity and radiation that continues for longer than any single star can burn. Even in this opening view, the edges of the mystery are visible. How does a heart so heavy grow so quickly in a young universe? Does the seed begin as a direct collapse from a vast cloud that never splits into stars? Does it grow through a burst of near-constant feeding, the rate set by the exact shape of the disk and the threads of magnetic field that carry angular momentum away? Do smaller black holes meet and fuse in a crowded early city of galaxies, each union leaving tremors in space-time and adding weight to the core? The calm tone does not demand an answer. It invites a long, patient search. Instruments across the spectrum already listen. Radio arrays, quiet giants with wide steel petals, hear the extended breath of cool gas and faint structure beyond the glare. Optical mirrors paying attention to fine detail see lines broadened by fast motion in clouds that circle far from the event horizon. Infrared eyes detect warm dust that absorbs the white blaze and reissues it in gentler shades, a sign that older outbursts baked grains and set them drifting like slow snow. High-energy observatories catch the hard accent of X-ray light, which speaks of violent neighborhoods close to the brink where gravity tightens every step and where particles rise in temperature until their collisions sketch a different, sharper register. Together, these notes form a spectrum, a chart that works like a map, layering clues into distance and density, flow and flicker. And the map, when read as a whole, whispers a promise that deeper listening will turn the lullaby into a blueprint of the hidden architecture. Near the center, the very shape of time changes. Light that tries to leave from close in must climb a steep slope, and in the climb it loses energy and falls to redder colors, a gravitational afterglow that adds warmth to the tone. Just outside the last safe orbit there exists a place where light can circle many times before escaping a phantom ring that delays the message and lengthens the rhythm. Inside the final boundary lies perfect quiet, an event horizon that sends no reply, a silence that is not emptiness but a rule. Because that rule holds without exception, the music from just outside becomes more precious, and the care with which it is gathered becomes a form of respect. Timing matters because small fluctuations reveal size. A change in the optical light that is followed by a change in infrared tells how far dust lies from the core. A ripple that moves from low energy to high energy, or in the other direction, tells which region answers which. By patient measurement of delays, the shape of the system becomes clearer without ever breaking the hush. The surrounding space also answers. Jets may rise as thin spears moving near the speed of light, but even when the jets are faint or angled away, their traces can be found in radio maps and in ghostly lobes that mark past episodes. Winds, perhaps less focused yet widespread, can drive material from the center, changing the chemistry of the host and enriching the spaces between galaxies. Dust made in the furnace of the core can seed future clouds far from the quasar, so that the quiet over time becomes a gardener. Every effect is both an imprint and an echo, and even now, before details are named, the balance between creation and removal steadies the scene. What the listener receives on a night of watch is a profound sense of order. The quasar does not flicker like a candle. It glows like a sea under moonlight, full of unseen currents, yet flat and even from a calm shore. The appetite of the center is vast, yet the pace of arrival becomes sustainable, because the web provides, and the halo gathers, and the disk uses what it is given. The outcome is not a final state, but an ongoing arrangement, a living equilibrium that can hold for a long span before the supply falters or the environment shifts. To rest with this light is to recognize that the universe allows such long balances to occur, and that within them even the greatest engines can sing softly. In that softness, the arc of the investigation begins, for calm is not the end of inquiry, but the perfect starting point. The next measures will move closer from halo to disk, from wind to ring of light, from ring to the very brink where silence rules, and with each step the tone remains unbroken, the same patient lullaby from ton 618, leading the way inward while keeping the night at ease. In painted ink on glass and paper, the first trace of ton 618 enters the record as a pale blue point on survey plates, a neat dot that receives a simple catalogue tag without ceremony, a name that reads like a filing code rather than a herald of enormity. Observers sweep the sky with wide photographic fields and objective prisms, sifting for unusual colours and odd spectra, and among the gathered lights this one is listed fixed to a number that stays calm on the page. The label says little, yet the object behind the label already resists easy categories because it looks like a star while disobeying the patterns that stars obey. A radio receiver tuned to the distant sky hints at a presence in the same area, and radio charts mark faint contours of emission, while optical observers return to the coordinates to test whether the tidy blue point might be more than it appears. Spectrographs spread the light by wavelength, and the broadened lines reveal clouds moving at great speeds, while the entire pattern is shifted far toward the red, a sign of distance and of space itself stretching the message as it travels. The combination of point-like image, great distance, and immense power signals a quasi-stellar object, the bright heart of a galaxy. Thus, a dry label begins to glow, not because the name changes, but because layers of understanding stack beneath it, until the simple tag becomes a door into a complex interior. The number persists through cross-references in radio listings, optical atlases, and later infrared and X-ray compendia, each edition tightening the net around identity. Fields from northern and southern stations are compared, and the point holds steady in position while its brightness wanders by small amounts across years, an early sign of the restless engine within. Coordinated campaigns lie in the future, yet the patience of repeated measurement lays groundwork for what follows, and the community begins to speak of mass feeding and of the deep well that can drive such light. By the time the term quasar takes root, TON 618 stands as a touchstone for ultraluminous nuclei at great distances, and later compilations place its mass among the heaviest inferred. Early estimates use line widths and the size of the region that responds to changes in brightness, and later work extends patterns from nearby galaxies to far distances where direct starlight is drowned. To pin a number to this distant heart is an act of translation, for the visible thing is a glow and a few shifting marks in a spectrum, while the inferred thing is a compact object of astonishing weight hidden by its own rule of silence. Initial instruments cannot resolve the host under the glare, so the host is first an idea, a necessary home for the nucleus, and the dark halo is a further inference, a scaffold to hold the gas that must flow inward to keep the light alive. With deeper imaging and careful subtraction of the point, spread function hints of structure appear as faint smudges around the point, traces that help fix the place of TON 618 within the larger web. In these early decades, the story is mostly spectral, about lines, and continua about slopes and breaks that sketch the hands of dust and scattering each, changing the colour of the light before it leaves for intergalactic travel. Grains formed in fast outflows absorb high-energy light and reissue it in the infrared, and so infrared observatories give a quieter view, in which the glare softens, and the cocoon around the engine becomes more legible. Radio maps built with long baselines search for the pencil marks of jets, those thin outflows that sometimes run for hundreds of thousands of light years. And here the radio voice is present but modest, a whisper rather than a shout, which raises questions about angle and environment. A jet aimed away from the line of sight would appear subdued even if strong, while a thick surrounding medium could choke a young jet and scatter its energy into a broad lobe. Catalogue notes begin to include such possibilities alongside measured facts, because the entry now sits at the crossroads of many instruments, and every new campaign adds a sentence to the quiet biography of the source. A code and a coordinate persist while the reality behind them grows richer, and this restraint allows a return to base facts whenever models grow ornate. At a fixed sky position rests a point whose light is stretched by expansion, whose power implies a central mass that tests ordinary formation scenarios, and whose environment shows signs of both feeding and feedback. The compactness of the listing mirrors the thing itself, which concentrates staggering energy into a region smaller than a solar system. Thus the path from plain name to living object becomes a lesson in patient inference, where a thin thread of data can support a broad span of understanding if woven with care. Each new measurement revisits the same modest entry and enlarges it so that the simple name TON 618 comes to mean an architecture of halo host dust winds, and a river of fire curving inward with a silence at the centre that remains perfect. In this way, the plane catalogue number proves not a cage but a key opening layer after layer from the time when light left the source, while galaxies were young to the present night, when the lullaby reaches across the dark and lands on a page steady enough to guide the next step inward. In the scaffolding of the universe, Ton 618 holds an address along a river of matter, a filament where gravity gathers thin threads into a continuous path that leads toward a deeper basin, and that quiet placement matters because it sets the pace of supply. Wide surveys reveal that galaxies do not sprinkle the void at random, but arrange themselves in long strands and crowded junctions, and within those strands the intergalactic medium streams like a cold wind sliding down gentle slopes, set long ago by the first ripples in the cosmic microwave background. Where the strand bends toward a node, halos grow, and inside a heavy halo, a black hole can inherit a generous pantry enough to keep the inner disk bright for a long interval. Observers test this picture with several lines of evidence. Lines in quasar spectra measure clouds of hydrogen along the sightline, a forest of small absorptions that sketches density fluctuations like tree rings, and near Ton 618. Those lines thin in a small zone, as if the strong radiation has carved a local bubble in which neutral atoms retreat, a proximity effect that confirms both power and environment. Narrow filters tuned to the glow of distant hydrogen seek faint companions around the beacon, small young galaxies that choose to form at the same ridge in the web, and counts in many quasar fields tilt high, hinting that bright engines often glow where supply lines meet. Whether Ton 618 sits in a clear overdensity remains a measured question rather than a fixed claim. Yet even cautious maps show that the surrounding sky is not empty, and that structure extends across scales far larger than any single galaxy. Gravitational lensing adds another form of cartography. Background galaxies seen through the wide neighbourhood bend into slight arcs and shears that record the presence of mass without the need for light, and when these shapes are stacked and averaged, the pattern yields a blur portrait of the dark halo in its outskirts. In such portraits, the halos that host bright quasars reach masses of many trillions of suns, enough to draw long cold streams through a hot envelope, and into the inner regions where the disk waits. If cold streams do survive the trip through the halo, they would slide inward at thousands of kilometers per second, while staying cool enough to avoid pressure support, a quiet delivery that can feed the center without the violent jolts of large mergers. Yet counts of tidal features and disturbed companions around many luminous nuclei show that collisions also play a role, and so the supply appears to be plural, steady streams plus occasional feasts. The radio voice of the field supports the picture of abundance. Diffuse radio emission on scales larger than the host suggests, past outflows that have stirred the circumgalactic medium, and those stirred regions can act as reservoirs from which material falls back, after cooling a slow fountain that recycles mass over time. The balance among inflow, outflow, and fallback creates a climate rather than a single event, and in that climate the central engine can maintain a near constant fuel pressure even while local weather varies. Dust contributes to the climate by trapping harsh light and reissuing it at longer wavelengths, and the distribution of warm dust around Ton 618 indicates clumps and lanes rather than a smooth shell, a geometry consistent with filaments reaching inward and with winds carving channels outward. Because the environment is layered, timing measurements turn into a three-dimensional map. A change first seen in the continuum and later in the dusty glow speaks to a ring of dust at a particular distance from the centre, while a later echo in narrow emission reveals slower gas in the outer neighbourhood, and in each echo the lag translates into a scale that can be compared with the expectations for a massive halo fed by streams. Across years of watching, these lags imply a spacious but not infinite reservoir, large enough to resist short droughts, but small enough to respond to long shifts in weather across the filament. The most puzzling feature is not that there is food, but that the delivery appears smooth across long stretches, a state that models once considered rare. Duty cycles for luminous quasars are often written as bursts, yet Ton 618 radiates with a steadiness that suggests either repeated on periods that blur together, or a sustained high state that endures while the filament remains well coupled. If the latter holds, then the cosmic web itself not only merges, becomes the principal architect of the light curve. In that scenario, cold streams aim along a few preferred lanes set by the large-scale potential like highways that reach into a city centre, and small satellites ride those lanes, adding both stars and gas in a gentle drizzle. The inner disk then converts the slow, coherent arrival into steady heat, and the steadiness becomes the lullaby heard across the dark. There are tests ahead. Deep integral field spectroscopy can search for faint fluorescent filaments around the quasar hydrogen lit by the central lamp and draped like pale ribbons, a direct view of the supply. Millimeter arrays can map carbon and oxygen in cool molecular form, measuring how far the rich chemistry extends beyond the host and whether it aligns with the suspected lanes. Improved weak lensing maps can sharpen the sketch of the enclosing halo and look for secondary peaks that would betray an assembling group or a forming cluster, a broader context that could further stabilize supply. If the map resolves knots along the filament near Ton 618. Those knots might themselves be small engines, episodic lights that turn on and off, while the central source remains calmly bright, a hierarchy that links the course of one black hole with the life of many neighbouring galaxies. Even if some observations fall short, the line of inquiry remains strong because the logic is geometric and gravitational at once. Matter follows the quiet rails of the web. Halos grow where rails cross. A deep potential creates a funnel feeds a disk sings in light, and light marks the address where all these flows meet. The address explains the calm without diminishing the awe, because the scale is so wide that even a measured explanation feels like wonder. Ton 618 rests where the universe is arranged for long patience, and in that patience the song continues, a steady note drawn from a network that spans hundreds of millions of light years, and yet converges silently and exactly at a horizon, no wider than a few times the orbit of distant planets around a single star. The filament carries the melody in from afar, the halo holds the key, and the hush around the core keeps time, a cosmic arrangement that lets the mind rest, while the investigation moves one layer closer to the source. The glare of Ton 618 wraps the host in a bright shawl so complete that the city of stars beneath becomes only a rumour of light, a gentle swell under a breaking wave, and to see this hidden home requires finesse rather than force, a slow unweaving of the central point. Observers begin with the shape of the point's spread function, the exact pattern carved by optics and atmosphere, or by a mirror in space, and they subtract that shape from the image until the leftover glow reveals faint arcs and smudges that belong not to the active nucleus, but to the galaxy around it. The Hubble Space Telescope and the James Webb Space Telescope bring a steadiness that helps this subtraction succeed, while adaptive optics on very large mirrors sharpen ground-based views until the stars shrink and the host swells into view. Even then, the host does not appear as a crisp spiral or a neat elliptical. Distance and surface brightness dimming turn structure into suggestion. A bulge emerges as a rounded plateau of light, and beyond it a loose envelope extends like a shallow tide with hints of lanes, where dust dims the starlight and whispers of knots, where new stars may be rising under the combined push of inflow and feedback. Spectra, gathered with integral field units, convert every small piece of the host into a record of colour and motion, and the colours imply a mix of older stars with a frosting of young ones, while the motion reveals a pattern that is neither a clean rotating disk nor a random spheroid, but a tempered blend, as if the galaxy remembers an earlier encounter and has not fully settled. The mass of the starlight accounts for only part of the grip that holds the outer lights, for velocities in faint gas and stars run higher than the visible matter alone would justify. And this excess tells of a dark halo whose shape is felt and not seen, an invisible shore that guides orbits on wide scales. Weak lensing signals in the surrounding field recovered by stacking many galaxies, and measuring the subtle shear sketch a median halo that stretches for hundreds of thousands of light years, and that weighs many trillions of suns, a platform broad enough to welcome steady streams of cold gas from the cosmic web. The molecular phase of that gas becomes legible when the Atacama Large Millimeter Array listens for carbon monoxide and other cool traces lines that sing softly from clouds too cold to shine on their own. Maps of that cool material suggest elongated lanes that reach inward from the outskirts toward the center, an architecture that echoes the large-scale filaments, but now at the scale of the host, with bars or warped features acting as conveyors that hand material from one radius to the next. Alongside these inward threads appear hollowed bubbles and faint cones that trace past winds driven by the nucleus cavities, where fast outflows once pushed, and where the gas now curls around the edges like smoke around a stone. The balance between inward lanes and outward hollows defines the climate of the host, a slow alternation between feeding and clearing that can proceed together in different quadrants, creating a symmetry that the stars then record as uneven growth. Chemicals carried by these currents confound simple stories. Heavy elements measured in the region near the nucleus appear rich, as if many cycles of star birth and death have already taken place, even though the universe at this distance in time is still young. Iron lines shine with strength that implies contributions from long-delay supernovae earlier than models once preferred, which suggests that the host or its ancestors formed stars efficiently in a first burst, and then continued at a high pace within the filament. Dust grains show a mixture of sizes and compositions that point to both stellar factories and the high-temperature processing that only the central engine can perform, a dual origin that places the host and the nucleus in constant exchange. Farther out, neutral hydrogen clouds mark satellites and streams that have not yet settled into the main body, and their velocities match the pull of the halo, rather than the visible galaxy alone, repeating the lesson that the unseen mass sets the broader stage. The morphology of the host bears scars and ornaments from this long weather. Low-surface brightness shells stand out in deep images. Once the central glare is calmed, the lingering footprints of past accretion events, while a faint tidal tail points toward a dim companion, as if the galaxy has reached out a long arm and is drawing a smaller partner inward along the common filament. If this story is right, then the host of TON 618 is not a static pedestal for a central light, but a living participant in an extended network, passing along resources gathered by the halo, while responding to the pressure and heat of the nucleus with changes in pace and pattern. All the while, the central point holds the eye. Even after careful subtraction, the nucleus leaves a soft echo, a reminder that every pixel near the core is touched by light from the inner engine, and that clean separation is more hope than guarantee. Analysts account for this by building models of the host and the nucleus together, fitting both profiles at once and checking whether the inferred stellar distribution obeys the same scaling relations that join black hole mass and bulge properties in nearby galaxies. Early fits suggest that TON 618 sits above those relations, with a central mass proportionally greater than the bulge would predict, if measured by local rules, a mismatch that has been seen in many distant quasars, and that fans the question of rapid early growth. Either the central black hole gains weight faster than the stars can grow in the inner host, or the bulge has not yet gathered its full share of mass, or the relation itself bends with time. Each option preserves the calm of the present image while widening the open space of interpretation. In this concealed home, the dark halo shapes the outer rhythm. The starlight carries a memory of past tides. The cold gas forms paths that bring nourishment inward, and the dust both hides and reveals turning harsh energy into warmth that blankets the outskirts. The picture is a compromise between what is seen and what must be inferred, and the compromise holds because every line of evidence points toward a generous structure that can feed and shelter the central engine without collapsing into either disorder or stillness. The host remains the quiet partner, and the halo the silent architect, and together they cradle a river of fire whose abating glare finally allows the eye to catch the faint relief of the city beneath. The next layer asks how each wavelength threads through this architecture, because a full map will require not just images and motions, but a continuous spectrum that turns light into a topography of temperature density and flow the better to follow the lullaby deeper without breaking its calm. In the spectrum of TON 618, each wavelength becomes a lane on a layered atlas, so that what seems a single white blaze breaks into bands that guide the eye through gas dust and energy, from the cool outskirts to the heated brink. At long radio wavelengths, wide dishes on high dry plateaus, listen for a low murmur that traces electrons drifting through magnetic fields, and for molecules turning inside clouds far from the furnace of the nucleus. The Atacama Large Millimeter Array resolves delicate filaments of carbon and oxygen in cold molecular form, and outlines lanes that point inward like paths worn by steady feet, while very long baseline radio maps search for needles of jet emission, and broad faint lobes that would keep memory of past episodes. In the submillimeter, grains of dust speak softly, warmed by light from within, and their combined glow draws an outline of a cocoon around the engine, thicker in some quadrants, thinner in others, already hinting that the environment is patchy, that supply lines and escape routes do not share a simple symmetry. Infrared light adds warmth and shape to the portrait. The James Webb Space Telescope and ground-based mirrors with adaptive optics find a wide bump in the spectrum that marks dust, which absorbs the harsh blaze and reissues it in gentler colours. The size of the bump and its exact slope tell how much dust lies close to the core and how the grains are made. Silicate features near 10 micrometers and 18 micrometers sometimes shine in emission, where older models expected absorption, a clue that the dust forms clumps with gaps, not a smooth donut so that heat can leak through and carve bright pockets, even while the broader shell still shades the city of stars beneath. In the near-infrared, narrower lines of ionized gas bracket the central point, and show motions that are brisk but not frantic, the signature of a region where stars and gas still obey the gravity of the host more than the pull of the inner disk. In optical light the point sharpens, and a forest of broad emission lines stands across the continuum, their great widths set by clouds racing at thousands of kilometers per second, clouds that feel the mass inside and answer with a chorus of motion. Changes in the continuum brightness flow into changes in these lines after a delay, and the delay turns time into distance, a calm arithmetic called reverberation mapping that places each family of clouds at a measured radius. Narrower lines sit above the broad ones like fine tracing speaking for a larger, slower region. Their steadiness across seasons anchors the whole spectrum and offers a reference point for shifts elsewhere. Polarization adds a quiet note to the map, showing that some of the optical and ultraviolet light does not travel straight from the disk, but bounces off electrons and dust grains, and the direction of the polarization betrays hidden structures, faint mirrors placed by nature to let the eye see around corners. The ultraviolet band pushes the flow toward high energy. There, deep troughs bitten out of the continuum mark winds that stride toward the observer at many thousands of kilometers per second, layered flows that carry heavy elements into the halo and beyond. The depth and shape of the troughs change over months and years, sometimes without clear relation to the overall brightness, as if clumps in the wind pass across the view like drifting clouds. The slope of the ultraviolet continuum turns down more sharply than the simplest thin disk would predict a bend that hints at a wind that robs the inner disk of heat, or at small grains that absorb the blue with uncommon appetite, or at a geometry that lets some inner light slip sideways into other bands. At yet higher energy, the Chandra X-ray Observatory and other orbiting instruments reveal a hard glow that flares on short timescales, evidence for a hot corona above the disk, where electrons near the speed of light punch the soft photons upward in energy, a process that ties the X-ray and optical bands in a dance of small leads and lags. Sometimes the X-ray spectrum carries a broad iron feature stretched toward the red by fast orbits and strong gravity, its shape a blurred echo of the inner radii where space itself curves. The path of light, and time runs slow. On rare occasions the X-ray slope softens more than expected, while the optical brightness remains nearly steady, as if the corona changes mood without a matching change in the disk, a decoupling that unsettles neat models and suggests that magnetic fields may redraw the energy budget on their own terms. Across all bands, the full spectral energy distribution rises like a long, smooth hill with gentle shoulders and hidden terraces that each advertise a structure. A warm bump in the infrared writes the radius of the dust. A blue lift sketches the inner disk. A shoulder in the submillimeter marks shocked grains that now cool. A firm shelf in the X-ray maps the corona. Yet every revelation arrives with a concealment. Dust warms the map but hides the host. A hard corona reveals the edge of the interior while masking the subtleties of the outer disk. Broad lines trace motions yet blend voices until individual clouds become a choir without faces. Coordinated campaigns tie this atlas together with time. When telescopes on mountains and in orbit watch at once, a change steps from band to band with measured pauses, and those pauses draw circles around structures with the precision of a compass. A brightening in the optical that later warms the infrared sets the dust ring. A slow echo in a narrow line comes later still from the outer gas. A quick X-ray flicker that leads the optical hints that the corona now whispers instructions to the disk rather than only answering it. At times the sequence reverses and the optical leads by a breath, a sign that heat born in the disk rises upward and stirs the high energy region. Because each band both reveals and conceals the truest map is the weave of them all. The spectrum gathers into a single continuous thread that runs from the cool outskirts through warm dust and hot gas to the harsh brilliance right above the horizon, and along that thread every twist translates into a physical place and process. The method remains exact. The tone remains soft because even as the data sharpen, the picture, immense distance and deep gravity smooth the edges into a tranquil, legible shape. When the atlas is read from end to end, the next page opens naturally, the inner river of fire itself, where the disk turns potential into light, and where the hush grows stronger as the brink draws near, a quiet invitation to follow the song inward. In the inner architecture of Ton 618, the accretion disk spreads like a luminous river wound upon itself, a flat whirl whose outer waters drift in wide circles, and whose inner waters tighten until the path becomes a plunge. Gravity provides the slope, angular momentum provides the resistance, and between them lies a narrow treaty enforced by turbulence, the tangled magnetic stirring that lets matter trade places and slide inward while energy and orbital memory move outward. The disk begins cool and faint where the host hands off, supply then warms by steady friction, so that colours grade from red to blue toward the centre, a quiet temperature ladder that turns potential into light. The James Webb Space Telescope careful ground-based mirrors and high-energy observatories hear this ladder in the shape of the continuum, a smooth rise across optical and ultraviolet bands that bends where the inner rings become too hot, and that bend draws a soft line around the last stable orbits. Close to that brink, atoms meet collisions so frequent that pairs separate, and the gas becomes a clean sea of electrons and bare nuclei. Their magnetic fields snag and release like braided ropes, lifting some particles above the surface into a hot, thin atmosphere that observers call the corona, while the rest remain in the plane and carry the weight of the radiance. The two regions talk in light. Soft photons from the disk climb into the corona and return as hard X-ray notes, while fast changes in the corona drop as gentle instructions that ripple across the disk and push a flare outward. Sometimes the instruction runs in reverse and a brightening born in the disk crests in the corona. A moment later, a sign that heat rises, and that the energy budget can be set from below or from above depending on how the fields arrange themselves. Line echoes measure distances in this inner country. Broad features from ions of carbon, magnesium and hydrogen respond with delays that shrink inward, and the pattern of shrinking delays forms an invisible scale against which the thickness of the disk and the tilt of the view can be tested. The broadest lines show vast speeds, clouds racing at thousands of kilometers per second, and their shapes skew toward the red and spread into long wings because strong gravity steals energy from the outbound light, and because orbits near the inner ring approach a significant fraction of the speed of light. Even the continuum carries the mark of orbital geometry. Slight polarization angles twist with wavelength as scattering layers change from electrons close in to grains farther out. An orderly rotation that reads like a compass on a map saying where the disk is thick where it thins, and how the inner funnel might open to launch a wind. The wind itself stands at the edge of this river of fire like a shore of foam. When illumination climbs above a threshold, atoms feel more pressure from light than from gravity, and sheets of gas peel away from the surface and arc upward, then either escape on the starward side or fall back as drifts that rain upon middle radii. The trace of this cycle sits in deep ultraviolet troughs that slide in speed and depth over months, as if clumps rise and dissolve within a broader steady stream. The presence of a wind turns the inner river into a living weather, because the wind cools the surface by scratching mass away, and because it steals a share of angular momentum, letting the remaining flow slip inward more easily. Models that once pictured a perfectly thin, smooth disk now accept a disk with scars and waves, with patches heated by magnetic reconnection and zones shaded by warps, and this more rugged portrait matches the small irregularities that coordinated campaigns record. Yet the overall tone remains calm because many small changes add like ripples on a lake that refuses to storm. A more difficult clue comes from the hardest light. At certain seasons the X-ray slope softens even while the optical band holds steady, as though the corona has altered the way it sifts seed photons, without calling for a matching change in the supply. That shift may mean that magnetic loops grow and shrink in height above the disk, changing the fraction of the sky the corona sees, or that pairs of electrons and positrons briefly multiply in the hottest pockets and change the ease with which energy passes through. If the latter holds, then the inner environment plays with the rules of matter creation and annihilation at a slow, persistent rate, a profound process smoothed by distance into a gentle sway. The innermost edge remains the essential boundary of the map. Just outside the horizon lies the last safe circular path, a ring, whose radius depends on whether the black hole spins, and on how fast and in which sense the spin runs. If the spin helps, the last ring slides inward. If the spin resists, the ring stands farther out, and in either case the position of that ring sets the highest colour the disk can produce and the steepness of the continuum near the ultraviolet bend. Indirect signs suggest that the heart of TON 618 turns quickly, because the energy budget appears efficient, and because faint hints of iron light shaped by strong gravity prefer a radius closer to the centre than a non-spinning case would allow. A fast spin also gives the inner rings a chance to drag space itself, a subtle whirl that edges orbits forward and that could seed small quasi-periodic sways in the light curve, sways so long in period for a mass of tens of billions of suns that only a patient archive across decades can catch them. The disk may thicken nearer the brink where radiation tries to support the gas against its own weight, forming a low inner wall that can shadow parts of the outer surface. Such a wall would explain gentle kinks in some time lags, and would give the wind a natural launch pad along the rim. Beneath the face of the disk, the chemistry finds no foothold because heat strips every bond, but farther out islands of dusk gather, where dust reforms and molecules can survive, and those islands act as registers for the changing light from within. When the inner engine brightens, a slow wave spreads to those islands and gives them a temporary glow. When the engine rests, the islands cool and the glow fades. In this way, the river of fire writes to the outskirts, and the outskirts reply with a measured echo, and the whole exchange becomes the metronome of the lullaby. The greatest surprise may be how such ferocity sustains such composure. The disk takes disorderly, clumpy supply and converts it into a near steady radiance through countless micro-events, each magnetic twist and viscous rub dissipating chaos into heat that leaves as organized light. That transformation, repeated ring by ring, hour by hour, year by year, lets an ultramassive black hole feed without a roar. TON 618 shows that when gravity is deep and the supply is broad, a river of fire can keep its surface smooth, even while the current below runs wild. The result is a shining plane that holds the eye and calms the mind, while pointing unerringly toward the brink where light hesitates and silence begins. Winds from TON 618 rise like pale banners that unfurl from the inner river of fire and sweep outward through the hidden city and into the wide halo, carrying heat metals and dust that together redraw the climate of the host. The signs appear first in the ultraviolet, where deep absorption troughs bite into the continuum and mark clouds accelerating at many thousands of kilometers per second, a layered procession that shifts its depths and edges over months as clumps drift across the view and as the lighting in the core brightens or rests. In the same light, broad emission lines narrow or broaden by a small amount, while their centroids tilt, a gentle reminder that fast outflows and fast orbits share the stage, and that the border between rising wind and bound cloud is not a fixed wall but a porous seam. High-energy eyes add a harder verse to the tale when iron in high states of charge imprints narrow blue-shifted notches, Upon the X-ray glow, a signature of gas that moves even more quickly and that hugs the inner disk before it escapes the kind of ultra-fast breath that can carry a large share of the engine's power outward in a nearly invisible form. Where this breath meets the denser layers above, the host shocks form and cool, and the cooling wake turns bright in optical forbidden lines that widen into wings and farther out into radio-free whispers that outline the rims of hollowed cones. Infrared light reveals the dust that rides these winds. The James Webb Space Telescope and the Very Large Telescope trace silicate features near 10 micrometers and 18 micrometers, not as simple absorption wells but often as broad emission, humps a clue that the grains gather in clumps with clearings between, so that heated faces glow while shaded faces remain cool, and the mix beams a warm chorus rather than a flat veil. The sizes of grains inferred from the slopes suggest that many are small, fine enough to redden the nucleus with a steeper curve than the dust of a calm spiral galaxy, as if the grinding and shattering within the wind has repopulated the dust with fresh fragments. Yet strange chemistry survives alongside the shattering. Polycyclic aromatic hydrocarbons, complex molecules that usually wilt under strong radiation, still carve faint notches and bumps in the mid-infrared spectrum, which implies that dense pockets shield them, or that they reform in the wake of shocks reassembled from carbon vapor, the way soot condenses from a flame. Even more unexpected molecules appear in the millimeter maps when the Atacama Large Millimeter Array listens for carbon monoxide, hydrogen cyanide, and formule lines that trace cool clumps that remain molecular while being swept along a stubborn survival that turns the wind into a patchwork of hot, warm, and cold. In some seasons, hydroxyl mesa flashes brighten and fade on the edges of the cones, a sign that dense gas and strong pumping coexist in small knots at just the right temperature, as if the wind itself builds small laboratories and then scatters them. The geometry of these outflows steadies into a familiar but not perfect hourglass. Ionized gas draws narrow cones that lean away from the plane of the disk, while molecular gas sketches broader lobes that wrap the cones like soft sleeves. The opening angle changes with time and with wavelength widening when the engine turns louder, and narrowing after long rests, a breathing motion read from the changing width of emission line wings and from the footprint of excited lines on the host. Along the rims of the lobes, star-forming knots appear, where shells plough into pre-existing clouds and squeeze them, and a ring of young clusters glimmers in deep images just outside the main glare, as if feedback both quenches and kindles, trimming the central supply while lighting small lanterns in the outskirts. That balance between removal and creation is the signature of a gentle regulator. Momentum carried by the wind can sweep channels clear and reduce fuel to the core, but energy deposited in the halo can later cool and fall back as a fine rain that resumes the inward drift, and so the wind and the supply enter a slow cycle, whose period spans millions of years, yet whose trace today is a quilt of bubbles, arcs, and lanes. Dust participates as both passenger and pilot. Radiation pressure pushes directly on grains, and the grains drag gas by collisions and charges, so that the most opaque clumps feel the strongest shove, and this selectivity explains why extinction curves steepen when the wind is lively and flatten when it rests. Polarization measurements across optical and infrared bands show that aligned grains rotate the plane of light by small angles that change with wavelength and position, allowing a map of grain paths and an estimate of how magnetic fields thread the outflow. In the hottest inner zones, grains should sublimate, but observations still find crystalline features mixed with amorphous ones, a contradiction that resolves if grains condense in the wind itself as it expands and cools, growing on the fly, from a mixture enriched by the engine and by fast supernova in compact star-forming regions near the core. The result is a blended pedigree for the dust part factory of stars part foundry of the quasar. Stranger still, the overall chemical budget appears mature in an era when the universe is young. Ratios among oxygen, nitrogen and carbon in the broad line region hint at heavy enrichment, while iron to magnesium patterns imply contributions from long delay explosions that should take time to appear, and yet the record shows them already at work. This tension encourages a picture in which early efficient star formation in the progenitor system floods the environment with metals very quickly, and subsequent inflow along the filament replenishes gas that is already seasoned, so that the wind now lifts a mixture familiar to much later galaxies. The Atacama Large Millimeter Array finds carbon in ionized and neutral form, extending beyond the host-marking ancient plumes that now cool and join the circumgalactic medium, a fossil spray that speaks to episodes when the engine blazed even brighter. Not every trace fits neatly. At times the ultraviolet wind fades while the X-ray signatures of fast breath grow stronger, suggesting that the outflow layers slide past each other in strength, and that geometry rather than simple luminosity sets which layer we see. At other times the infrared warm bump brightens without a matching change in the optical, a hint that dust near the poles receives more direct light, while the equatorial view remains shaded, as if the clumpy shell rearranges its openings like moving weather over a coast. Now and then radio maps show slender faint spines that suggest narrow jets testing the path through the same cones, tracing routes that may have been cleared by earlier winds, and the gentle presence of these spines supports a partnership in which even a quiet jet can lend structure to a wind-dominated feedback. Through all of this, the lullaby does not break. The wind breathes steadily enough that the wide glow remains even, and distance smooths the quick flutters into a soft, comprehensible pulse. Ton 618 does not rage. It exhales. Each exhalation carries dust and chemistry. Outward, writes arcs upon the halo, compresses, one cloud disperses another, and then thins into the dark where the signature lingers as a faint enrichment of the spaces between galaxies. In time, the same material returns along cooled lanes or arrives anew from the filament, and the cycle repeats a slow respiration that maintains the calm by preventing either runaway growth or sudden starvation. Strange molecules, resilient grains, and layered flows turn the outflow into a moving archive of everything the engine has been doing, saved in the composition of each knot and in the shape of each shell. To follow that archive is to read the feedback that keeps the system in balance, and to stay within the balance is to hear the song continue patient, and even as the investigation steps inward from wind and dust, toward the tight rings of light where gravity bends time and where the hush grows deeper still. Jets from Ton 618 test the boundary between whisper and spear, as if the engine toys with the idea of launching near light-speed knives, and then chooses restraint, leaving signatures that are suggestive rather than overwhelming, and that invite a careful reading of geometry and weather. At radio wavelengths, very long baseline interferometry gathers the point into a compact core with a hint of short extension, a small asymmetry that could be the seed of a jet seen at an angle that turns speed into modest length, while lower resolution maps detect broad, faint halos that might be the cooled ghosts of earlier eruptions. The spectrum of the core hovers near flat across centimetre bands, a trait common to compact self-absorbed knots at the foot of jets, yet on longer wavelengths, the spectrum steepens into the slope of aged electrons, as if energy once carried outward now fades in place. Polarization fractions remain low on average and patchy in detail, a sign that magnetized gas along the path rotates and scrambles the plane of light, an effect that strengthens when the medium is dense and clumpy, and this fits the picture of a wind-carved halo, where pockets of ionized plasma wrap the narrow channels that any jet would prefer. Orientation compounds the puzzle. If the jet points away from the direct line of sight by several tens of degrees, then the headlight effect that would brighten one side and dim the other softens, so that fast motion looks tame and apparent speeds in the inner knot stay below the dramatic superluminal show seen in blazers. In that arrangement, the jet is real, but demure, a narrow current that threads the same polar corridors outlined by ionized cones and warm dust, borrowing paths that the wind has kept relatively clear. Environmental resistance offers a second explanation. A thick central medium buoyed by radiation pressure and stocked with clouds and grains can load a newborn jet with mass and slow its spreading energy sideways into a bubble, instead of letting a sharp spear run far. Radio maps that show roundish lobes without bright terminal hotspots support this gentle strangling a regime, where feedback behaves more like a hand on a rheostat than like a switch. A more distant influence also speaks. The sea of relic radiation left from the first light of the universe grows more energetic when seen at earlier times, and at the era of Ton 618 that background becomes dozens of times stronger than in the present day, so that electrons in a large-scale jet would more readily lose energy by boosting background photons into X-ray light, instead of by radiating in radio bands. In this case, a jet could be genuinely powerful yet look faint in radio while appearing as a thin X-ray line, a mismatch that has been observed in other distant systems, and that makes a quiet radio map an incomplete verdict. Deep exposures with the Chandra X-ray Observatory can search for such linear glows. Even a non-detection would still frame the energy budget by showing that inverse Compton cooling and environmental scattering conspire to hide a spear in soft light. Traces of past activity hide in spectra as well as in images. The curvature of the radio spectrum at very low frequencies measured by wide-field low-frequency arrays carries the fingerprint of old electrons that have cooled for millions of years since the last strong push, and if such curvature bends just so in the field around Ton 618, it would argue for a duty cycle in which louder epochs alternate with quiet seasons leaving shell upon shell of fading glow. In that scheme, today's modest core would be the latest verse in a long song, with earlier refrains preserved as broad wings of diffuse emission. The shape of any faint structures may even hold a memory of precession. If the spin of the black hole and the plane of the accretion disk drift toward alignment over time, the jet direction can slowly sweep painting an S-shaped pattern on large scales that becomes smudged by distance but still legible in careful stacks. A slow sweep would also explain why some arcs in optical emission lines bend differently from radio halos, suggesting that different outbursts lit different directions through the same medium. Magnetic architecture matters at the launch point. Theories that draw power from a rapidly spinning horizon require a strong vertical magnetic field pinned on the inner rings, a magnetically arrested state that can choke inflow and direct energy into a tight beam. If Ton 618 lives below that threshold with ample flux but not enough to lock the inner river, then a weaker jet should follow, coaxed more by the disk wind than by the spin of the hole, a braided structure with a fast spine and a slower sheath that trades momentum with the surrounding outflow. Radio polarization angles that twist smoothly along the tiny extension fit this picture of helical magnetic fields, while sudden jumps in angle hint at shocks where the spine meets a denser clump from the wind. On scales of thousands of light years, the jet, if present, may decollimate into a soft plume that slips along the cone walls instead of drilling a straight path, and such plumes would account for radio halos that are brighter along edges than at centres. Gas entrained by this drift can cool behind weak shocks, and later fall back, feeding the same lanes that brought material in, turning what looked like a one-way spear into part of a slow circulation. Tests remain clear even under the hush. Monitor the compact core across years to catch small correlated swings in radio and high-energy light that betray the growth and fading of inner knots. Measure time delays between bands to decide whether flares begin in the corona, an echo in the jet, or rise in the jet, an echo in the disk. Use very long baseline interferometry to track the position of the radio core at multiple frequencies and look for a core shift that signals self-absorption along a conical outflow. Combine those tests with deep low-frequency imaging to net the relic wings, and with refined polarization maps to recover the pattern of ordered and tangled fields. Whether the outcome favors a whisper guided by wind, a spear muted by angle, or a two-part braid that shares power between spine and sheath, the larger lesson persists. The engine does not waste energy. It arranges pathways. In TON 618, those pathways appear to favour broad winds for heat and momentum, with jets playing a quieter structural role that still matters for carving roots and stirring the halo. The lullaby holds because each mechanism finds a stable register rather than a shout. The jet, even as a whisper, adds a steady undertone that firms the rhythm by which supply and feedback keep time, and that undertone, smoothed by vast distance, becomes part of the gentle, continuous note that guides the listener to the next question. How small variations across days to years encode the hidden architecture in delays and echoes that only patience can unfold. The light of TON 618 does not stay perfectly still. It trembles by small amounts across hours, days and years, and in those gentle quivers lies a ruler for the hidden interior, because every change that begins in one region arrives later in another, and each delay translates into a distance travelled at the speed of light. Observers gather long patient light curves, with robotic surveys on broad fields, and with pointed campaigns that lace together nights on different continents and orbits in space, so that the continuum in optical and ultraviolet bands becomes a steady line of time with tiny waves. When the continuum swells, the broad lines answer after a pause, and the length of the pause marks the radius of the region that emits those lines. A shell of fast clouds that listen to the disk and then glow. The method is simple in spirit and careful in practice, because clouds at different distances answer with overlapping delays like echoes in a canyon, so one must disentangle many soft returns to find the structure that fits them all. Sometimes the red side of a broad line brightens first, and sometimes the blue side leads, which shows that inflow and outflow both play parts, and that the chorus of clouds carries more than one motion at once. Farther out, warm dust brightens later, still days turning to months as the wave of light reaches grains that wrap the nucleus in a ragged ring. When the ring glows, an infrared bump rises, and the timing of that rise traces the radius where dust survives without turning to vapour, a radius that moves slightly as the central lamp grows and rests, so that the map breathes with the engine. Higher in energy, the hot corona above the disk adds a harder rhythm. In many seasons, the X-ray light leads by a small step, as if quick heating in the corona rains down as a gentle instruction that the disk then answers. In other seasons, the optical leads by a breath, as if heat born in the inner rings puffs upward to refresh the corona. These reversals say that energy flows both ways across short spans, and that magnetic fields, not only gravity and radiation, set the order of cause and effect. In radio bands, the core sometimes flutters after an optical swing, as if a knot forms at the jet base when the inner disk becomes lively and then drifts outward and cools. The delay between the optical crest and the radio crest marks the time for a knot to travel until it becomes transparent. Even when the jet is modest, such a chain can be seen as a very small radio brightening that follows a days-long optical rise, a quiet step in a long dance. The statistics of the flicker carry meaning beyond any single event. When brightness differences are plotted against the time between measurements, the curve rises smoothly at short spans and then levels at long spans, as though the engine is a calm wanderer that takes larger steps when given more time but refuses a runaway. This behavior measured in many quasars suits a picture where countless small zones in the disk and corona shift their heat by small amounts, each with its own memory, so that the combined light looks like a gentle, damped walk. Larger masses smooth faster changes, smaller engines jitter more quickly, and Ton 618, with a heart that weighs tens of billions of suns, naturally shuns fast drama, turning what could be sharp flares into long sighs. Yet within the smoothing there may be long faint cycles. If the inner ring precesses because the black hole drags space, or if the warp in the disk slowly nods, the light curve might carry a low broad swell on timescales of many years, and attentive archives can search for that quiet sway. The environment in front of the quasar also leaves a hand on the clock. Intervening dust reddens and smooths, and plasma in our own galaxy can make the radio core twinkle by a small amount, like a star, a scintillation that adds tiny fast flicker unconnected to the engine. Removing those foreground tricks requires comparisons among wavelengths and among multiple instruments, which is why coordinated campaigns matter as much as depth. Gravitational lensing by small masses along the line of sight can also pinch and stretch the path of light by almost invisible amounts, and while Ton 618 is not known to be strongly lensed, a weak micro-lensing whisper could still shift a feature by a fraction of a day and confuse a naive measurement. Careful teams therefore compare many events over many seasons and keep only patterns that repeat. In the best seasons, the delays break into a fine map. The shortest lag connects the inner optical continuum at bluer colours with the slightly redder bands, a sign that a flash born near the brink propagates outward through the disk as a cooling wave. Next comes the response of the broad line region, first in high ionization species, from closer in, and later in lower ionization species, from farther out, a graceful ladder that mirrors the decreasing heat with increasing radius. The dust ring answers still later, and the narrow line clouds in the outskirts, governed more by the host than by the engine, barely budge at all within the span of a human project. With this ladder in hand, observers turn the quiver into a scale measure. The lag in further radius combine with the width of the line to read the orbital speed, and the result becomes a mass for the hidden heart. For Ton 618, these steps point to a mass so large that even long delays remain surprisingly small, because the inner light we see comes from a wide swath whose light travel time is still short compared with the years we can watch. Small mysteries persist at every rung. Some events show strong ultraviolet changes with muted optical response, as if a wind siphons heat from the disk before it can reach lower energy bands. Other events brighten infrared dust that lies along the pole more than dust in the plane, hinting at a clumpy geometry with moving openings. Rarely a short X-ray dip precedes a mild optical drop, as though the corona briefly shades the disk before easing. Each oddity suggests a slightly different structure, or a temporary change in height, thickness, or angle, and each calls for new nights of patience, rather than a rewrite of fundamentals. The lesson of the flicker is that a great engine can be mapped with the gentlest of motions, and that distance turns restless local weather into a soft regular tide. In this soft tide, the lullaby strengthens because the pauses and echoes resolve into a pattern that the mind can hold a system of clocks, nested within clocks, all keeping time to the same deep beat set by gravity and flow. With timing in hand, the path inward turns toward the domain where light itself hesitates, where orbits of pure light circle before escape, and where the curve of time becomes visible in the very shape of the spectrum. In the near country of light around ton 618, geometry becomes an instrument and time becomes pliable, so that even a single ray can trace a complex path before it returns to the open sky. Just outside the last safe circle for matter lies a narrow demarcation that invites light to orbit a photon sphere, where a beam can loop once, twice, or many times before it escapes each lap, paying a toll to gravity and shifting colour toward the red. The ring is not a wall but a precarious track, and small changes in angle decide between flight and capture, so the region acts like a lens with a careful yet nervous hand magnifying and delaying whatever lies behind it. Rays that skim this track arrive late and fainter, carrying a slow echo of the inner disk, and because the delay grows with the number of loops, the echo becomes a ladder of soft repetitions that blend into the calm glow seen from afar. Polarization adds a second voice to this map. As bent light walks its curve, the plane of vibration twists, and a gentle rotation of polarization across wavelength and across the tiny image encodes whether the inner surface is flat-puffed or warped. Even without a direct picture, careful sums over many seasons tease out a preferred angle that drifts when the inner disk nods a nod set by the steady tug between the spin of the black hole and the tilt of the incoming streams. The photon sphere also frames the red shoulders of spectral lines born near the brink. Iron in the hottest rings emits a note that would be sharp in a quiet laboratory, yet here gravity and speed broaden it into a wide skewed wing that leans far to the red. The exact bend of that wing and the soft ledge on its blue side work like a stencil for the innermost orbits, saying how close the last bright ring rests to the horizon, and whether the central spin draws that ring inward. During calm intervals the wing sits steady. During small flares it breathes its red tail, deepening as the inner flow warms and shifts the balance of light nearer to the rim. Timing weaves through these clues. When a short brightening begins near the brink, the first arriving light is hard and slightly polarized. Then a slower component follows as rays that have circled the track once or twice finally peel away. The span between the crest and the echo depends on mass and on spin, and for a heart that weighs tens of billions of suns, the delay runs long enough that echoes merge into a low persistent hum. That hum, invisible to a single night, yet legible in patient stacks, is part of the quiet that reaches the observer, a blend of direct notes and late chords that the photon sphere has stretched and set gently back into the field. Some rays do not return. A slightly inward lean sends them across the horizon, and their last visible act is to lend the ring a darker outline by removing alternate paths from the sky. If a perfect sharp image were possible, the boundary would appear as a thin stubborn circle that repeats within itself a nested ring laid by rays that have looped different numbers of times. In practice, distance and the small size of the ring spread these structures into a single smooth edge on a point. Yet even that smoothing teaches, because any small departure from perfect roundness in the unseen ring would drift the polarization angle and adjust the relation between the iron wing and the continuum, and tiny mismatches of that kind do appear at intervals gentle hints that the inner funnel is not purely round but slightly lopsided by a warp or by the pull of a stream that does not join the plane at once. The flow right above the brink answers in kind. Electrons in the hot corona sift soft photons into harder notes, and those notes bear the same bends and delays as their seeds, so that the very shape of the high-energy slope changes by a hair when the inner geometry changes. In seasons when the slope softens while the optical band holds steady, a simple reading says that the corona has expanded or leaned, letting more rays take longer paths through the curved field before they reach the observer, and the added delay shows as a barely longer tail in the high-energy light curve. Even the wind listens to this geometry. Clumps rising from the disk see a sky that is stretched and dimmed near the rim. If the balance between glare and gravity shifts by a little, the launch angle of the wind tilts by a degree, and that small change accumulates across many parcels into a measurable lean of the ultraviolet troughs. In this way, the photon sphere draws thin lines across many bands, none large on its own, all consistent when laid together. Gravitational lensing by material along the line of sight can imitate some of these tricks by delaying and nudging brightness. But such lensing acts nearly the same on all colours, while the near ring prefers certain energies and locations, so careful differences between bands separate the local bending from foreground glass. A rarer effect lies in weight as well. If two bright patches in the inner disk sit at different longitudes, their images can overlap after multiple loops, producing a faint pattern in which a single feature appears more than once with different delays and colours. For a mass like this, those repetitions are separated by many hours or days, far longer than in a small black hole, and they smear into the slow sway that the archive records as a gentle excess of power at long timescales. The beauty of this near ring is that it turns extreme physics into a softening agent. Curved paths, red shifts, and time delays do not sharpen the light into harsh flares. They lengthen and warm it, drawing the spectrum toward a rounded shape and the light curve toward a patient cadence. The photon sphere therefore becomes both boundary and balm, the place where the last traces of the inner storm are edited into an even tone that can cross the deep without losing coherence. Ton 618 thus sings through a filter made by gravity itself, and the song gains its calm not in spite of the depth, but because of it. Following that calm into the next layer brings the edge proper, where the event horizon stands as a perfect rule rather than a surface, and where the brightest energies rise just outside a silence that no instrument can cross, a silence that shapes knowledge by what it forbids, and that gives the lullaby its purest and most certain rest. At the brink of Ton 618 and the last bright rings pour out their energy, while a perfect quiet waits one small step closer in a quiet so complete that it shapes everything that can be known. The event horizon is not a surface that glows or cracks. It is a rule in space-time that forbids reply. Matter that crosses this boundary leaves no signal behind, yet just outside it. In the narrow neighbourhood where the last stable orbits give way to a plunge, the engine reaches its most intense efficiency, and the river of fire sends out its final light before the fall becomes irreversible. Gravity bends time so sharply here that processes which would be frantic in a calmer field appear unhurried to a distant observer, stretched into soft curves and lengthened notes so that the catastrophe of infall is edited into peace. Electrons in the thin corona sift the last soft photons into hard ones, and those hard notes carry the stamp of curved paths and losing battles, with redshift their edges rounded their highest pitches, warmed down as if the field itself were a patient instrument. The iron line, borne a few rings out, spreads wide, its red wing deepening as the inner surface brightens for a moment, then easing as that light sinks closer to the boundary. The change writes a slow breath rather than a flash, because each photon must climb the full height of the well before it can rejoin the open sky. Magnetic fields twisted tight by rotation funnel energy along the poles, yet even that extraction, if present, refuses haste in such a deep mass, and the outcome is steadiness rather than spikes. The wind that rises from the disk feels the edge. There is a threshold beyond which radiation can no longer push matter outward from the very inner rings, so the wind launches a step farther out and leaves the final few orbits to fall in cleanly. The ultraviolet troughs that trace that wind therefore thin during calm intervals near the brink, and thicken at larger radii, a gentle redistribution that betrays the growing dominion of gravity as the horizon approaches. The jet, if a narrow one exists, drinks power from the rotation and from the fields that drape the inner regions, but in an ultramassive heart the timescales are long, and the jet's influence on the immediate glow becomes a mute presence, more scaffolding than shout. The silence of the boundary also governs violent encounters. A star that wanders too near a modest black hole is torn into a long stream that shines as it dissolves, but for a mass of tens of billions of suns, the tidal pull at the horizon can be gentle enough that a main sequence star would cross intact and vanish without a public flare. The city around the core thus misses a kind of firework, and the observer receives only a slight smooth gain in mass, written into the long budget of growth. Gas clouds more easily torn still feed the last rings, yet their final surrender takes place below the threshold where messages can leave, and so the story remains a one-sided ledger whose credits are seen and whose spending is inferred. Instruments reach for this place with ideas rather than images. The Event Horizon telescope draws direct rings in nearer galaxies, where the scale on the sky is large enough for millimeter waves to resolve the shadow of the horizon. But TON 618 lies too far for a picture, so the same physics is traced by spectra, by timing, and by the coherent way many small signs shift together. A modest softening in the high-energy slope while the optical remains steady fits a slight rise in the coronal height, and a longer path near the curved edge. A tiny change in polarization angle across a season suits a gentle nod in the inner disk as it seeks alignment with the spin. A subtle deepening of the red wing in iron when the continuum warms points to the last bright rings inching inward under a favorable spin. Each clue is small, together they form a consistent hush that says the horizon is doing its work. The rule at the boundary extends to information as well as to light, identities of particles, patterns written in the swirling gas, the detailed state of magnetic knots. All of these become unreportable after the crossing, and the only records that remain are the conserved totals that the exterior can measure, such as mass spin, and charge the simple descriptors that make the outside solution clean and free of detail. In practical terms, this means the engine erases the fine print while keeping the headline, and in human terms the effect is a deeper calm because the messy particulars of infall are reduced to an even contribution to the glow just outside. Quantum whispers add a footnote but not a disruption. Hawking radiation would leak from a small black hole with a measurable temperature, but an ultramassive heart is so cold by that measure that the emission is effectively nothing beside the great flood from the disk, a fact that reinforces the impression that the horizon is not a lamp, but a shadow that orders nearby brightness. If a compact object spirals in, it would send waves into space-time ripples that today's detectors hear only from nearer lighter pairs, yet the principle stands. Even the ringing of the geometry itself would be a sound that fades as distance and mass smooth it into a rest note. The horizon's quiet has consequences across the host. Because catastrophe produces no fireworks of its own, the climate of the galaxy is set by processes just outside the brink, by the heat from the disk and the breath of the wind, not by shocks at the boundary. Feedback therefore takes the form of slow pressure and sculpting, and the halo answers with adjusted flows rather than with blast waves. The large-scale calm that surveys record is born from this local rule. There are moments when the boundary's discipline becomes almost visible. During a coordinated campaign, a small optical crest arrives. A near-simultaneous softening in high-energy light follows, and narrow changes in the ultraviolet wind whisper that the launch region has shifted outward. The sequence aligns with a push in the inner rings that ends not with a flash but with a hush, as if the final act of each parcel were to disappear behind the rule rather than to speak. This repeated pattern writes the lullaby's deepest bar energy peaks before the line silence sits at the line. Knowledge stops at the line, and all that remains to the listener is the softened, lengthened, honest glow from just outside, which is more than enough to draw a clear map and to invite the next question. What lies beyond the rule must be approached by thought and by theory, for no ray returns from that quiet to guide the eye, and so the narrative must step carefully from observation into inference, carrying with it the discipline that the horizon has already taught. That knowledge can be firm and calm even when it meets a perfect and beautiful limit. In theory, the interior of Ton 618 becomes a landscape that observation cannot touch, yet reason can sketch a country governed by the same gravity that bends the outer light, but pushed to a depth where classical rules meet quantum whispers and ask for a truce. The classical map says that inside the horizon all paths lean inward and end at a place where curvature grows without bound a singular goal, where the known fabric ends while a companion rule called cosmic censorship guards that extreme by keeping it hidden behind the horizon, so that distant space keeps its order. For an ultramassive heart, the curvature at the horizon is gentle, and the fall is long, but the destination would still be that unreachable centre where classical ideas stop, and so the interior remains the hidden half of a sentence that the exterior alone can finish. Quantum thought replies that the sentence should not break that information written in the motions of matter, and light must keep its tally even when the horizon forbids reply, and this demand creates the famous tension between a calm exterior and a vanishing interior ledger. The paradox began with the idea that a black hole glows faintly by a quantum process that makes paired quanta near the boundary, with one flying out and the other falling in, and that the glow would carry almost no memory of what formed the whole. For a monster like Ton 618, that glow is colder than any practical background, and its loss of mass across the lifetime of the universe is essentially nothing. Yet the principle still asks to be settled, because it concerns the bookkeeping of nature at the most basic scale. Several answers move across the stage without breaking the calm. One says that the horizon is a perfect rule, but not a blank rule, that it keeps a soft record on its surface in delicate ripples of gravitational and electromagnetic memory. A gentle hair that can store the fine strands of information and later return them as a pattern in the glow, preserving the identity of what fell, even as the exterior stays smooth. Another answer says that an observer who rides the fall would see nothing odd at the boundary, while an observer who stays outside would watch information appear to sit on the boundary and spread along it, as if the three-dimensional story had been reprinted on a two-dimensional page, a holographic view that reconciles both perspectives without a clash. A bolder suggestion replaces the interior entirely with a new phase of space-time, a gravitating star of exotic pressure, or a dense quantum foam whose surface sits where the horizon would have been and reflects a small fraction of ingoing light, yet the slow, even light curves of Ton 618 show no crisp echoes that such a surface might create, and the quiet therefore leans in favour of a true rule, rather than a disguised wall, at least within present sensitivity. Others imagine that entanglement itself builds thin bridges in the fabric, so that the falling mate of each quantum pair and the outgoing mate remain one system connected by a tiny non-traversable link, a vision in which the bookkeeping of information rides invisible threads that keep the exterior story whole without granting a path for messages to cross back. There is also the sharp proposal that quantum bonds at the boundary must break to let the bookkeeping proceed, a break that would create a sheet of fierce quanta at the horizon, a firewall that would burn any infailure. Yet the great mass, the stability of the inner disk, and the absence of harsh bursts near the brink argue for a soft boundary rather than a violent one, and many physicists prefer gentler accounts, where entanglement reshuffles rather than snaps. Still, another line of thought draws a curve for the information contained in the faint glow, a rise at first as the glow grows complex and a fall later. When correlations in the glow begin to reveal what had gone in, and on paper, this curve can be made to behave well if one admits that certain parts of the interior must be counted as belonging to the exterior radiation by a subtle accounting of quantum regions called islands. In that case, the horizon remains quiet. The exterior keeps its pledge to conserve information, and the paradox dissolves into a careful ledger that no current instrument could check for a giant whose glow is all but absent. Yet the conceptual structure still supports the picture that the rule at the boundary can be kind and exact at once. Even if the deep interior stays a secret, its nature would still touch the outer world in tiny ways. Some exotic interiors with surfaces close to the horizon predict faint late reverberations when in falling waves reflect and return after a long pause. Yet the patient stacks of light from Ton 618 show a smooth cadence, with no crisp, repeating afterbeats, a quiet that fits a horizon which does not answer at all. Other models that remove the singular goal and replace it with a core of new matter, or a bounce into another region, suggest small departures from the steady relation among inner features, but the coherent way that iron wings high-energy slopes, polarization angles, and time lags move together favors an exterior obeying the usual rules of gravity with a silent interior, and so the more exotic revisions remain illustrations rather than demands. Even so, the hidden country could still be hospitable to seeds of speculation that fit the calm. The spin of the centre, likely high, could support a long-lived inner atmosphere of fields and currents that carry angular momentum inward and outward, even as the last rings brighten, and the meeting between that interior atmosphere and the falling flow could write the simplest possible answer. On the boundary, a smooth addition to mass and to spin with no visible fuss. If the interior does hold a quantum foam or a tangle of thread-like excitations, the effect at the boundary would almost surely be to lengthen and soften light, rather than to sharpen it, because every route to the observer must still climb a great slope, and the slope smooths everything into the same patient register. Thus the big lessons stand. The horizon remains a rule that edits the storm into calm. The outside fields keep faith with the simple charges of mass and spin. The information book stays balanced by a subtle surface memory, or an invisible network of correlations. And the singular goal may be either a true end of the classical map, or a pocket where new law takes over, but in every account the distant light remains even. Ton 618 therefore becomes a stage on which theory can rehearse ideas without breaking observation, a place where gentle data hold the centre, while speculation explores the interior with care. From this quiet brink, the inquiry turns outward again to ask how such a giant came to be so soon and so heavy, how seeds formed and supply gathered and mergers helped, and how the calm that now reigns was prepared by a history that the light can still trace in echoes and in chemistry across the wider field. To explain how Ton 618 grows so large so early, the narrative must rewind to the first scaffolds of galaxies, when the universe is young and gas cools along dark filaments into halos that have only just begun to shine, and in that dawn two kinds of seeds present themselves, one born from stars and one born without stars at all. The first path begins when the earliest metal-poor giants end their brief lives and leave behind black hearts of a few tens to a few hundreds of suns, small kernels that can in principle swell by steady eating. Yet these remnants must climb an enormous ladder to become ultramassive, which requires long stretches of feeding near the classical Eddington limit, where light pressure balances gravity, or brief seasons above that limit, when geometry and clumps allow inflow to find paths that light cannot easily block. The second path begins larger, a direct collapse in which a vast pristine cloud under a strong bath of dissociating light avoids fragmenting into stars, stays warm and sinks as a whole, until a single heavy object forms with a mass of perhaps 100,000 or 1,000,000 suns a head start that needs fewer cycles of near maximal feeding. Both paths then join the same river of growth, a sequence of accretion episodes and mergers that add mass, while preserving enough calm to keep luminous phases long rather than explosive. The environment around Ton 618 favours such a program. A heavy halo at a node in the cosmic web can deliver cold streams for a long span, and those streams feed a broad disk that converts potential into light with high efficiency, a trait that implies significant spin and a tight inner ring, which in turn shortens the time needed to turn infall into radiation, while keeping overall growth surprisingly fast when the supply is generous. Mergers along the filament add both fuel and companions, and when galaxies coalesce, their central black holes sink toward the common centre. By friction against stars and gas form a pair, and later merge, releasing ripples into space-time and leaving behind a heavier, often rapidly spinning remnant. Whether spin helps or hinders depends on how the disk aligns. A long episode of coherent inflow from one direction tends to spin the heart up and produce a bright, efficient engine that shines strongly for each kilogram swallowed, which slows growth if the limit of radiation pressure is strict. In contrast, a messy, chaotic sequence of many short episodes from changing directions tends to keep the spin moderate, lowering radiative efficiency and letting the same inflow add mass more quickly, and in a young, crowded environment the latter pattern may dominate until the system settles. Winds and jets play regulation rather than termination. They open channels and trim the immediate pantry, but also stir the halo from which some material later cools and rains back a fountain that lengthens the duty cycle rather than ending it, and this gentle feedback suits the steadiness observed in the light from Ton 618 across long spans. Direct collapse remains attractive because the strong metal lines near the nucleus today do not rule out a pristine origin long ago, since enrichment can occur quickly in the first few 100 million years. A massive seed simply allows the timeline to fit inside the youth of the universe without demanding impossible rates. Yet even with a heavy seed, growth wants seasons of high inflow that skirt the classical limit, and several mechanisms can allow such seasons without breaking the calm. A thick inner disk, supported partly by its own radiation, can hide the brightest zones from most lines of sight, letting inflow continue above the naive cap, while the observed glow appears steady. A clumpy, inhomogeneous surface can create low opacity funnels, along which gas slips inward while light escapes elsewhere, and a magnetically arrested state can briefly throttle inflow and then release it in pulses that once smoothed by mass and distance assemble into a calm plateau rather than sharp spikes. Meanwhile, the host and halo gather and deliver, bars and warped lanes in the starlight hand angular momentum, outward cold gas flows inward along dust, rich streams and minor mergers add fresh clouds that stall and then sink, all of which build a reserve that can carry the nucleus across quiet external weather. The high mass of Ton 618 compared with the bulge implied by scaling rules in nearby galaxies suggests that the black hole wins the race early, either because the seed is already heavy or because the center spends more time in the high state than the stars around it can match, or because the relation itself bends with time as halos grow faster than bulges in the first half of cosmic history. Simulations that include cold streams, clumpy disks, and multi-phase feedback reproduce this bend by letting gas aim efficiently at the center in massive halos while star formation is partly suppressed or delayed in the bulge by turbulence and heating, and the observed dust and chemistry near Ton 618 fit a story where central growth and enrichment run ahead of the broader city of stars. Gravitational waves from early mergers could in principle kick the kernel from the center, yet a deep potential and a long stream of follow-up gas pull it back, and each return may bring a new bout of feeding and a slightly altered spin accumulating mass without producing chaos in the light curve. Over very long spans, the integrated glow from quasars like this one roughly equals the mass now locked in dark hearts across galaxies, a simple ledger that says the main path to growth is indeed through luminous phases rather than hidden consumption alone, and Ton 618, by shining so powerfully, confesses to being shaped by such long bright meals. The specific balance among seed-steady feeding above-limit episodes and mergers likely changes with epoch and environment, and the present calm need not reflect the past storm precisely. The broad radio halos and fossil carbon beyond the host hint that earlier chapters may have been louder, with stronger outflows that now rest. Yet the continuity of supply along a filament and the climate set by a generous halo both argue that the key ingredient is not a single miraculous event, but a sustained alignment of channels that deliver disks, that convert winds, that regulate, and mergers that add without derailing the flow. In that sense, multiple paths converge on one mystery, not because they contradict, but because they cooperate. A moderately heavy seed shortens the hour. Cold streams feed the disk, feedback carves roots but keeps the pantry stocked short. Misaligned episodes keep efficiency moderate and growth fast rare. Mergers add larger steps and the mass climbs to the extreme without ever demanding a shout, the whole journey smoothed by gravity and distance into the same calm tone heard today. Thus, the growth of Ton 618 becomes a lesson in how a universe that is young and filamentary can still build a giant by patience and arrangement rather than by violence alone, and the lullaby remains intact as the story turns outward again, asking how this one engine imprints its scale on the field around it, how its light and breath change neighbours, and how the echo of its presence travels across the young cosmic web to leave a fossil signature that will be read long after the feeding slows. In the wide field around Ton 618, the engine's influence travels far beyond the host, leaving signatures in gas dust stars, and in the faintest background glow a layered fossil that records how a single core can shape a young region of the universe. Close in outflows, hollow broad cones that thin the interstellar medium along the poles and heap it along their rims, and where those rims compress older clouds, they kindle necklaces of clusters that ring the nucleus like small lanterns, while in the shadowed plane the same pressure drenches the central lanes with turbulence that slows fresh stars and lets the pantry of cold gas reorganize. As the wind breathes over many cycles, it rearranges chemistry, lifting carbon, oxygen, nitrogen and iron from the bright inner rings and dusting the outskirts with heavy elements that change how clouds cool. Gradients that would tilt steeply in a quiet spiral become gentler, and ratios such as nitrogen to oxygen drift high near the core and flatten with distance as the mixed halo shares its new wealth. The narrow line region, spread over thousands of light years, holds this memory as skewed profiles and wide wings that still point along the axes of past cones, even when the present outflow seems mild, a kinematic fossil that keeps its direction after the weather has moved on. Beyond the starlight, the circumgalactic medium settles into a multi-phase halo, where hot, warm and cold streams coexist, and background sight lines through this halo collect small absorptions from carbon, silicon, oxygen, and hydrogen at distances of hundreds of thousands of light years each, with velocities that prefer the same angles. Mapped by the inner cones, a quiet alignment that says feedback has carved channels all the way to the borders. In deep radio and millimeter maps, the same medium glows faintly from old electrons and from cool molecules adrift in filaments that arc around the host. Those filaments are likely the survivors of earlier episodes, first pushed then cooled, now floating as reservoirs ready to fall back and continue the slow fountain that keeps supply steady. On still larger scales, the light of TON 618 draws a bright bubble into the forest of distant hydrogen that lies along the line of sight, a proximity zone where the usual thicket of Lyman alpha absorptions thins and shifts, its lines pushed outward as radiation warms and ionizes local gas. The same clearing sometimes appears sideways as a transverse proximity effect, when a background beacon passes behind the region and shows a softened forest, where the quasar's lamp has washed the web. In helium lines, even subtler traces appear, for the hard spectrum from the corona can help finish the patchy rionization of helium at these epochs, leaving a warmer stripe in the intergalactic medium, whose temperature then cools slowly and marks the passage of a bright season. Long after the lamp has faded, dust follows the journey. Grains formed or reworked near the core ride the wind into the halo and beyond, and delicate features in the mid-infrared reveal crystalline faces mixed with amorphous skins, far from any star factory evidence that some grains grow or anneal in the outflow itself. When those grains wander into the intergalactic medium, they become seeds for future clouds along the filament, so that the quasar not only sculpts the present, but also primes the next round of structure. Energy injection leaves a subtler imprint as pressure. Stacked views of the microwave background around luminous quasars hint at warm bubbles of gas on scales of hundreds of thousands of light years. And while a single system like TON 618 cannot be cleanly isolated at this distance, the principle holds that long, steady breath can raise the temperature and pressure of the surrounding medium, enough to be felt as a gentle lift in background, light a sign that feedback writes itself onto the canvas of the universe as heat as well as light. The host stellar record keeps pace with these imprints. Age maps across the faint bulge suggest that the very center grew quickly and finished earlier than the outer parts, while shells and low-brightness plumes that surface in deep images testify to past minor mergers that delivered fresh gas and then faded into the envelope. Together, these traces argue for a growth pattern, where the black hole pulled ahead, the bulge followed more slowly, and the halo fed by the filament acted as the ever-present stage on which both could change without collapse. That tilt away from nearby scaling relations becomes part of the fossil, a heavy heart for a still-building city, a signature that later epochs may relax but that remains obvious while the universe is young. Neighbors feel the presence as well. Counts of small galaxies around the beacon often run high, and some show disturbed gas or enhanced narrow emission in alignment with the quasar cones, as if the wide breath both prunes and pollinates, quenching in some directions while encouraging starbirth in compressed knots elsewhere. Beyond the obvious companions, very faint streaks of fluorescent hydrogen sometimes appear when the central lamp paints the cosmic web itself. Thin strands lighting up for a time as if the universe were tracing its own veins under a bright torch. Even where a narrow jet seems modest, its structural role helps keep corridors open, offering paths that winds reuse so that the memory of a spear becomes a set of guide rails for the next breeze. Over long spans, the imprint deepens from event into climate, periods of strong outflow enrich and heat. Then the medium cools and returns along the same gravitational slopes that first gathered it, and the cycle repeats with a cadence set by the halo and the filament, rather than by any single flare, which is why the present scene can look calm even while the fossil record shows action spread across space and time. The sum of these effects is not a single verdict, but a family resemblance among many measures, softer metallicity gradients aligned kinematics in halo absorbers, warm dust in cones cleared proximity zones in hydrogen, possible pressure bubbles in background maps, age tilts in bulges, faint fluorescent streams around the host, and an offset black hole to bulge ratio that announces early central victory. None of these alone proves the whole, but together they draw one continuous line from a silent horizon through an organized disk and outward into a shaped environment that will carry the memory long after the song quiets. Thus, the imprint of Ton 618 on a young universe is neither a scar nor an accident. It is a careful embroidery of heat, chemistry, motion and light that echoes across scales, and even in its breadth that keeps the lullaby intact, because every pressure and every clearing, every ring of clusters, and every darkened lane always points back to a calm interior whose steady rhythm wrote the pattern with patience. The investigation now turns to the instruments and campaigns that will refine these faint signatures, listening not for a shout, but for an ever clearer whisper, the better to keep the night at ease while the map grows precise and the quiet grows deep. In the years ahead, the next view of Ton 618 gathers not from one eye, but from many that open together a quiet choreography of telescopes and archives designed to keep the lullaby intact while sharpening every measure. The James Webb Space Telescope continues to fold warm dust and faint starlight into clean spectra, its near-infrared and mid-infrared instruments tracing silicate humps, polycyclic aromatic hints, and the cool shoulders of molecular lanes, while refined calibrations shorten the uncertainty on tiny time delays between the bright inner river and the glowing dust ring. The Vera C. Rubin Observatory begins long even watches that spin out dense light curves across seasons, letting small quivers in the continuum paint a more exact ladder of echoes, and making room for the possibility that a slow, broad cycle marks the nod of the inner disk, where the spin of the black hole and the tilt of the inflow seek alignment. On high desert summits, giant mirrors more than 30 meters across turn their integral field spectrographs toward the host, and its halo recovering the motions of faint gas cloud by cloud, separating lanes that bring supply from shells that preserve old breath, and testing whether the bulge, the ring of clusters, and the outer envelope keep the same rhythm that the nucleus sets. With spectrostrometric care, these instruments weigh the broad line region by watching the smallest shifts in a line center as the continuum rises and falls, building a three-dimensional sketch of the fast clouds that until now have been a chorus without faces. Millimeter arrays push outward and inward at once, longer baselines and sharper receivers in the Atacama Large Millimeter Array Map, carbon monoxide, hydrogen cyanide, 4 mil, and faint hydroxyl mesa knots, all the way from the outskirts to the rims of the wind-carved cones, while time domain campaigns at these wavelengths follow the cooling of shocked grains after each gentle flare, turning the dusty cocoon into a slow barometer. Low-frequency arrays and the great network foreseen for the square kilometre era listen for old electrons that have drifted for millions of years, their curved spectra curating a museum of past outbursts. The same instruments count minute turns of the plane of polarization from Faraday rotation to trace the soft twist of magnetic fields through the wind and the halo, and to decide whether a quiet jet has braided the outflow into a stable corridor. Very long baseline experiments at millimeter wavelengths. Cousins of the Event Horizon Telescope cannot draw a sharp ring at this distance, but can still measure a shift of the radio core with frequency, a sign of optical depth along a conical flow, and can watch a compact knot grow and fade on a path that links the base of any jet to the glow of the corona and the inner disk. High-energy eyes prepare their own deep breaths. A high-throughput X-ray observatory will hear broad iron light respond to changes in the continuum with delays that prefer the inner radii, a reverberation so close to the horizon that its shape tightens limits on spin and on the height and texture of the corona, while present spacecraft keep watch for the softening and hardening that speaks for pairs, for magnetic reconnection, and for the slow sway of the photon sphere's lens. In the wider field, new cartographers stitch the environment. SCIS surveys with fine weak lensing maps and deep spectroscopy from space and ground plot the dark matter basin that holds the host recover satellite counts and their motions, and follow the thin fluorescence of hydrogen where the central lamp paints the nearby web. Narrow band images tuned to the distant line of hydrogen draw ribbons that drape toward the core like pale veins, a direct view of supply. The Euclid mission and its companions trace these structures, while the Nancy Grace Roman Space Telescope promises still wider portraits, in which proximity zones and mild overdensities stand out as soft halos around the beacon, and together they test whether the address in the web is a single crowded knot or a longer confluence of streams. Farther ahead, a space-based observatory for ripples in space-time prepares to hear the mergers of massive black holes at early times, setting a background against which the life of TON 618 can be placed, since a population of such giants requires a history of unions as well as of long meals. At the same time, patient timing of pulses across the sky continues to weigh the lowest notes of that background, making the orchestra of assembly audible, even when no single pair is seen. Polarimetry grows more precise at every band, turning small angles into maps of scattering dust alignment and hidden geometry. Time-resolved polarization makes the inner nod and any warp legible as a slow rotation, while the outer cones show how grains turn and how magnetic lines thread the wind. Throughout, coordinated campaigns become the rule rather than an exception. Nights on different continents and passes in orbit are braided into single sequences, so that a brightening caught in optical light is met at once by tuned slits in the infrared, by millimeter ears on the plateau, and by high-energy watchers above the air closing the gaps through which ambiguity once slipped. Careful algorithms trained on the calm itself learn to separate foreground tricks from true echoes, to find weak long delays under stronger short ones, and to discover when geometry rather than brightness has changed. The expected harvest is clarity without violence. Maps sharpen, but the tone stays even. Horizons remain rules, not stages. Winds continue to breathe rather than to blast. Jets keep their structural role without overturning the climate. The halo answers with slow fountains. The web maintains its rails. The likely surprise is not a sudden revision, but a gentle accumulation in which many small consistent signs pull a few uncertain numbers into focus. the degree of spin, the exact breadth of the dust ring, the height of the corona in quiet and in mild unrest, the pattern of lanes that feed the inner disk, the fraction of growth that came from mergers rather than from streams. When these settle, the giant's portrait will look still and sure, not because mystery has ended, but because the unknown has been hemmed in by a ring of careful facts that are themselves soft and patient. The lullaby then deepens rather than fades. With every instrument the light becomes more legible, with every season the timing becomes a cleaner clock, with every map the environment becomes a calmer stage, and the quiet around the horizon grows clearer as a chosen register rather than an absence. Ton 618 continues to sing, across the dark in a tone made by gravity and smoothed by distance, and the next eyes, by agreeing with one another, will let that tone carry farther, easier and truer, so that rest and inquiry remain companions as the narrative comes to a gentle pause and leaves the night unbroken. In the late hush, the light from Ton 618 softens into a patient glow that seems to smooth every edge of thought, a steady radiance born from a river of fire that never rises to a shout, only breathes in long, even lines. The halo holds its quiet shape. The lanes of supply drift without hurry, and the wind that once wrote cones and shells now blends into a warm envelope that settles the field. Within the inner rings, time stretches, bends, and then lengthens each note, until a single tone remains the gathered sum of many small acts that have become one calm song. Across the wide web, thin threads of hydrogen rest in faint relief dust cools to a gentle ember, and the memory of past seasons folds into the background like tide marks on a flat shore. The host keeps watch as a pale city under a bright sky, its stars untroubled, its lanes at ease, its long conversation with the nucleus reduced to slow exchanges of light and shadow that never disturb the evenness of the scene. The photosphere sifts the last high notes into warmth. The horizon keeps perfect silence, and the space between these two becomes a cradle, where motion and heat dissolve into a tranquil beam that crosses the dark unbroken. Instruments that have listened begin to rest as well, their records complete for now, their measures in agreement, their small differences softened by the weight of shared patterns. What remains is the sense that gravity can be gentle when distance is vast and time is generous, that even the deepest engine can choose a quiet register, and that the night itself accepts this, carrying the song onward through clean, empty space. The story holds open questions without tension, lets wonder slow its pace, and lets the calm stand. Ton 6. 118 continues and the dark remains kind.